I mean, that's what we are doing. We are in orbit. We're going to be there forever, actually, but the nominal mission length is 4 years. During those 4 years, we'll be looking down on the system, at the planet. We will be encountering some of the moons in the Saturn system. In fact, we will have something like 82 satellite flybys in the course of 4 years. This is unprecedented in magnitude. So I'm going to start with Saturn itself, telling you what we found. Saturn is a gaseous planet. It is banded, very delicately banded, like Jupiter. In fact, it has all the same kinds of features we find on Jupiter: the clouds, the eddies, the vortices, the waves, and so on. They're only deeper at Saturn in the atmosphere because Saturn is colder and there's more haze above these cloud layers, and so we have a difficult time seeing them in the visible. But we know where to look. We've carried lots of spectral filters to allow us to probe to different levels of the atmosphere. And so we can examine Saturn at particular wavelengths. And this is a near-infrared wavelength that allows us to see structures. And you can see, this is a movie we've made of our images, and you can see lots of activity. The imaging scientists have their eye right now. Well, they have their eye on lots of things, but one intriguing feature is this band in the southern hemisphere has lots of these dark oval storms about 1,000 kilometers across. It's kind of like Florida, lots of storms going in and out. And what we're finding, just one example of the kinds of things we're finding, we knew these storms died, unlike storms on Earth which peter out, these die by merging. But we had never seen, until Cassini, we'd never seen a storm actually get created. So now we have found storms that get created. They get created, in fact, in association with big eruptive events like this one here, which we have reproduced in garish false color, which everybody loves. So over the course of the mission, we're going to be producing a lot of movies of the Saturn atmosphere, because that is the best way to examine the meteorology, is to look at things in motion. And we should be able to develop a three-dimensional picture of what's going on in the Saturn atmosphere. We're interested in this because we don't know presently what energizes the winds in Saturn's atmosphere or Jupiter's atmosphere, or even our own for that matter. So we have a lot to gain by studying another planet like Saturn. The rings, of course, are the reason why Saturn is the icon in our solar system, and they are a tremendously beautiful visual spectacle. They're 1 light second across. They're about 280,000 kilometers across. They would fit in nicely between the Earth and the Moon, and wouldn't that be a fantastic sight to come out one night and see Saturn's rings hovering above your head? But although very solid looking, they consist of lots of particles, billions and billions of particles, and all in independent orbit around the planet. This is an artist's depiction circa 1983, but actually it still reproduces what we think the ring particles look like today. They range in sizes from the size of houses all the way down to the finest